Hello, hello, I'm audible. Hello, 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 I'm audible. Hello, I'm audible. Okay, now I'm audible. Wait. Okay, hello everyone. This is Irshad and welcome to our channel. It is Basis of Mathematical Science. Uh, so here, this is my first live, so I'm going to start. So I'm going to In this live, I'm going to discuss top 10 most known indefinite integral questions which may appear in your board exam. This year board exam. So, uh, if there is any, so I hope you all are going to. Um, this will be helpful for you all as this is my first live है so मुझसे कुछ गलती हो जाए उसके लिए इन एडवांस निकल ग्लिचेस और वॉइस नहीं आ रही है वीडियो क्वालिटी अच्छी नहीं उसके लिए आई एम सॉरी सो लेट्स स्टार्ट आई एम गोइंग टू शेयर नाउ आई एम गोइंग टू शेयर माय स्क्रीन it yeah, as my screen is visible to all, so the first type of question is this integral here integrand is x upon x square plus 1 x square plus 8. Let me check the voice. Okay, it's coming. So how we are going to integrate this integral? So as we can see, whenever we encounter this type of integral, it is in the form of px upon qx form. So we try to check whether it is in the form of dash x upon fx into g dx. As you can see, x square differentiation of x square gives x 2x. Here we can say it is in the form of f dash x upon f of x. So we are going to take f of x as t. So here, as you can see, can we go for a partial fraction? No, because here, as you can see, both the factors x square plus 8 has the power 2 means they are quadratic polynomial. It is not factorizable x square plus. So we are going to take in this case we are going to take square as t. Okay. So now when we differentiate, this implies x square will be t minus 1. So when we differentiate this x square plus 1 t, we get 2x equal to dt. Okay. So we replace now the integral will become x t x upon x square plus 1 x square plus 8. Now when we replace this, what we will get? X dt by 2. So this becomes dt by 2 whole upon x square plus 1 become t times. Now we replace x square as t minus 1. We will get t minus 1 plus 8, which is nothing but 1 upon 2 integration upon t times t plus 7. Now we can use here partial fraction. So what we are going to do, we are going to write 1 upon t plus partial fraction form a upon b upon t plus 7. Now we can 1 will be equal to a times plus 7 times a. Now we compare the constant term and the coefficient of t. Here we can conclude that 7 is equal to 1 and 8 is equal to 0. Here a is by 7 and b will be, what we will get, minus 1 by 7. सो जो लोग अगर मुझे इंस्टा पे लाइव है और मुझे आपको सारी स्क्रीन स्क्रीन क्रॉप दिख रही होगी, तो मैं सजेस्ट करूँगा आप बायो में जाके कि ये जो चैनल है उसके लिंक पर क्लिक करके ये लाइव वहाँ से यूट्यूब पे देख सकते हैं. ओके, सो दिस इंटीग्रल बिकम integration of, now we replace the 1 upon t plus 7 as 1 upon t 1 by 7 t plus 1 by 7 t plus 7 we get 1 by 2 integral 1 by 7 integration of by t minus 1 by integration 1 upon t plus 7. So what we will get 1 by 2. Okay, now this integral 1 by 2. Now this integral 1 upon t, we can write a integration of 1 upon t log t. Now this integral 1 upon t plus f, it again gives log of t plus f. We can place constant term c. 1 of t, this give by 7 log t. We can use the property of, here we are going to use property of log a minus log b gives log a upon b. Now we multiply this becomes 1 by 14 log t plus 7 t plus c. Now what we have taken t here? Now what we have taken t here? We have taken t as x square plus 1. So this will be equal to 1 upon 14 of x square plus 1 upon this t plus 7 becomes plus c. Now we can remove this. As you can see, x square is always going to be positive. So this becomes 14 log x square plus 1 x square plus 8 plus this is the required answer. It's this type of question. In this type of question, as you can see, we are not going to directly use a partial fraction. First, we are going to use a substitution method. Then we go for a partial. Is this clear? Anyone who is watching live? Is it clear? Anyone who is watching live? Please make a comment. Hello, I'm audible. Is my voice is clear? Hello. Hello, I'm audible. Is my voice is clear? Hello. 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 Okay. I'm audible. Let me check that. Okay. So, what is the second type of question? Okay. So, what is the second type of question? Look here. This second type, or we can say second question. 1 upon integration of 1 upon x raised to the power 7 minus x dx. Look here, whenever you encounter this type of integral, 1 upon whenever you encounter this type of formula, x raised to the power m. Okay. Whenever you encounter this type of formula, x raised to the power m plus x, or it may appear in this form, r upon 1 upon x raised to power 6, or we can say here power can be m. So we can write xm minus 1 plus 1. So what we are going to do, we are going to divide this power. Whenever we are going to divide x is over m minus 1, or we can write it in this form. How we are going to write? We are going to write x is over m minus 1 times as when we divide x is over n minus 1 numerator and denominator, what we will get? We get x is over m 1 upon x is over m. So here if it is the power m, so here the second term in the bracket will become 1 upon x is over m minus 1. So whenever you encounter this type of problem, here it can be plus minus sign, it can be plus minus sign. Okay. So here it is in this form of x is over 7 minus x. So what we are going to do, we are going to write this integral 1 upon x is over 7 minus x dx integral this. So what we are going to do, power is 7. So in the bracket, when we take out this x is over 7, we are going to write this as x is over 7 in the bracket 1 minus x is over 6 dx. Okay, yeah. So what we are going to do, we are going to take this term, the bracket term as t. We are going to take this term, this bracket term as t. So it will be 1 minus x. Let 1 minus 1 upon x is power 6 as t. So when we differentiate this, what we will get? We will get minus 6 1 upon x is to the power 7 dx equal to dt. Dx upon x is equal to minus dt upon 6. Can we write like this? So our integral change into 1 upon x 7 minus 1 x dx into this will become minus dt upon 6 upon this dx upon 7. So in the denominator, what we will get? We will get t. It is nothing but minus 1 upon 6 integration of t with respect to integration of 1 upon t. So how we are going to integrate this? We know integration of dx upon x plus. Here log is nothing but it is a natural log. Log of x is nothing but a natural log. Means we are talking about base e. So in this integration becomes minus 1 upon 6 log of mod t plus c. Here what we have taken t here? T as 1 upon 6. We can take this minus sign in the inside. What we will get? We will get 1 upon t plus c. This becomes 1 upon 6 log. What we have taken t here? 1 minus 1 by x is plus 6. Okay. This becomes 1 upon 6 log. This become x is power 6 upon x is power 6 minus 1. So this integral 7 minus x dx become 1 by 6 log x is power 6 upon x is power 6 minus 1 plus c. Is it clear? Dx become okay. This is the second type of question. It may ask in your this here as a 2 marks question. This type of question may appear as a 2 marks, or it may appear as a 3 marks also. Now, the type 3, or it's a third question. So whenever you encounter this type of integral where we have e raised to power x function attached to any other function, we have e raised to power x function, we are going to write this whole integrand as in this form, e raised to power x f dash x form, because when we write in this form, so the integration of this function becomes e raised to power x c. Directly we can write it. So what we are going to do, we are going to do some manipulation here. So what we as we can see here, x minus 1. So we are going to take this term x minus 1. We are going to take this one as x minus 1 plus t. So what we will get, this implies x 1 plus t. So when we differentiate t, what this implies equal to dt. Okay, so the integrand becomes x minus 3 x minus 1 whole cube to power x dx. So what we are going to do, I don't need to erase x plus f dash in this form dx. Integral will be x. So this integral becomes, replace x minus 1. So here x is 1 plus t. So we write 1 minus t whole upon e raised to power plus t. This integral becomes t minus 2 upon t e raised to power 1 plus t को we can write e raised to power 1 plus t as e times t dt. What will times integration of e raised to power t, here when we becomes t t dt. As we can see, this integrand becomes this form. Integrand becomes this form. So what we are going to do, as you can see, we here take f of t as 1 upon t dash will become cube, which is f dash t. So this plus dash t will become is what of. So this integration e is equal to e times this integration become t times 1 t square c. Is it clear? This line is clear because we have written e raised to power x f of x plus f dash x times dx. So this integration become e times e, which is equal to e times t square plus c. Now we replace every term in terms of x. Now we are going to write each term in terms of x. Here e raised to power t plus 1 become e raised to power x, or t square become x whole square plus c integral in x minus 1 dx power x minus 1 square plus c. Is it clear? What is the fourth question? Look, how we are going to solve this
Okay.
question.
What is the what is the fourth question?
Let me check if there is a timer is
Look,
available or not.
how we are going to solve this question? I'm going to give
I think it is
you a timer for this question. Let me check if there is a timer is available or not.
okay. Try to think.
I think it is not
Try
available.
to think how we are going to solve this type of question.
Okay. Try to think.
What
Try to think how we are going to solve this type of question. What manipulation we are going to use. Sorry. Hello. Hello, I'm audible. Hello. Hello, I'm audible.
hello, 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 I'm audible. Okay. Just a minute.
Hello.
Hello.
Hello, I'm audible.
Okay. It is.
Okay. Just
Okay.
a minute.
So how we are going to solve
Hello.
this type of question? As you can see, there are many terms of trigonometric terms:
Hello.
sine theta,
Okay.
cos theta,
It is.
cos square theta. So how we
Okay.
are going to
So
simplify
how we
this
are
type
going
of
to
question?
solve this type of question? As you can see, there are many terms
So
of
what we are going to do?
trigonometric sine theta, cos square theta. How we are going to simplify this type of question? We are going to do.
Wait. Hello. Okay. So whenever this type of question appears, so what is the method? How we are going to solve this type of question?
Okay. So whenever this type of question appears, so what is the
So what we are going to do?
method? How we are going to
We are
solve
going
this
to
type of
write
question?
this integral. We will try to write this type of integration as f of sine
So what
theta
we are going to do?
times
We are
cos
going to
theta d theta,
write
or
this integral. We will try to write
cos
this type
theta
of integration
times
as
sine theta d
f
theta.
sine theta times cos
As
theta
you can see,
or
here the sine term,
f of cos theta
here we can see
theta d
this
theta.
integral is of the type of this.
As you
So
can see, here the sine term.
hello.
Here we can see this integral is of the type of
So
this.
what we are going to do?
this form.
we are going to rewrite this equation, this integral,
Hello.
in the form of 3 sine theta minus 2
So what we are going to do? We are going to rewrite this equation,
5
this integral,
minus cos square theta
3 sine theta minus 2
minus 4 sine theta d theta.
cos theta whole upon minus theta d theta.
Okay. Okay. So we can rewrite it as 3 sine theta. We are going to write in
Okay.
form, the first form, this form.
Okay.
So
So we can
3 sine
rewrite it
theta
as
minus 2 times 5 minus, we can write
we
as
are going to write in this form.
minus 1 plus
This
sine
form.
square theta minus 4
So
sine theta
3 sine theta minus 2
d theta.
times 5 minus we can write as minus plus sine square theta minus 4 sine theta theta.
Hello. Hello.
Hello.
Am I audible? Okay.
Hello.
So this become, wait, here cos theta is, so this
Am I
become
audible?
3 sine theta
Okay.
minus 2 upon 4
So this
plus
become
4
here
minus
cos theta
4
is
sine theta plus
so this
sine
become
square theta
3 sine theta
cos theta d theta. As you can
to
see, this
upon
integral
4
become
plus
of this type. So
4
when this integral
theta
appears in this form, we are going to
square
take the
theta d
argument
theta.
of
As
this
you can
value
see,
sine theta
this
as
integral
t
become of
as
when this
t.
integral
So when we,
appears in this form,
so we are going to take sine
argument
theta
of this
as
means sine
t. Now we
as t
differentiate this.
as t.
Cos
So when
theta
we
d theta is equal to dt.
we are going to take sine theta as t. Now we differentiate this.
Now we replace each term of this
Cos
integral.
theta is equal to dt.
This integral become 3t minus 2 upon
Now we replace
4t minus
each term of this
4t
integral.
plus t square.
This integral become
Now cos theta d theta become dt
3t minus 2 upon 4 minus 4t plus t square. Now cos theta d theta become dt.
Is it clear?
Is it clear?
Is it clear, everyone? Okay. So now what we are going to do?
Is it clear, everyone?
We will write in this form. Now this integral 3t minus 2 upon 4 minus
Okay.
4t plus t
So
square.
now what we are going to do?
Okay. We are going to write this form.
We will
3t
write
minus
in
2
this form.
upon
Now
4 minus
this integral 3t minus 2 upon 4 minus
plus
4t plus
t
t
square
square.
in the partial fraction form. How we are going to
Okay.
write?
We
We
are
are going
going
to
to
write
write
it
this
as
form 3 to
dt of 4
4
minus
minus
4t
4t
plus t square plus b whole upon
plus t square
4
form. How
minus
are we going to
4t
write?
plus
plus b upon 4 minus 40
a
b
times
square. This becomes
wait
3
wait there is a
as
audio issue.
a times
Wait, if okay. Sorry, anyone who is watching live, please give your reaction
okay.
so that I can understand that you all are understanding.
Sorry,
Please react
anyone who is watching live,
when
please
anyone is watching.
give your reaction so that I can understand that you all are understanding. Please react when anyone is watching this live.
This implies pt
Okay,
minus 2 as minus 4a plus b
minus 4 p plus
plus
b.
2at.
This implies
Okay. So when we compare what we will get comparing the coefficient of
minus
constant term
4
we will get
plus b
a is equal to
2a.
3 by 2 and
Okay,
minus 4a plus b as
so when we compare what we will get, comparing the coefficient of
when we
constant
substitute
term,
this
we will get
value.
a
As you can see, this coefficient
3
2a will be equal to 3a because the
and
coefficient of t
minus
will
4a
be equal
plus
in the
b
both
as
side and this term
minus 2.
constant term minus 4a plus b
This becomes, when we substitute this
minus
value,
4a plus b
as you can see,
the
this
constant term
coefficient
which is minus 2.
2a will
So
be
it
equal
will
to 3
become
because the coefficient
minus
of t
3 by
will
2
be equal
plus
in the
b is
both
equal
side,
to
and this term constant term minus 4a
become
plus b
minus 6. So minus
minus 4a plus b will be equal to the constant
6
term which is
minus 2
minus 2.
gives b
So
equal to
it will
4.
become minus 4 times 3 by 2 plus b is equal to minus 2.
So this integral become
Minus 6.
we are going to write
Minus
this
6
integral
will
3t
transfer
minus 4
here.
upon
It will become
4
6
minus 4
minus 2 will
as
be
a times
equal to 4.
here a is
So
here a
this
is
integral
minus 4
become,
plus 2t here
we are going
it
to
will
write this
become
integral 3t minus 4
here
upon
a is 3
4
by
minus
2
2 square as a
upon
times. Here a is
4t plus t square plus
here a is
now b is 4
2t.
so we are going to write b
Here
4 upon
it is a as 3 by 2.
4 minus
Here a
4t
is 3
plus t square
upon 4 minus 4t
dt. Can
square
we write it like this? Yes. This
plus.
becomes 3 by 2
Now
into
b is 4.
minus 4
So we are going to
plus
write b
upon 4 minus 4t
4
plus
minus
t
4t plus
square
t square
dt plus 4 times
t.
1
Can
upon
we write it
4
like this?
minus
Yes.
4t plus
So it
t square
is 3 by 2 integration of plus 2 upon 4 minus 4t square dt
hello
plus times 1 minus 4t plus t square dt.
hello it's clear
Hello.
this line is clear hello so this integral become
of the
Hello.
form this integral. This integral will
Is it
become
clear?
of the form
This line is
f
clear.
dash x
Hello.
upon f of x form. So when we encounter
So
this
this
integral,
integral
we take the denominator as t.
of the form,
It will become the
this integral,
integral. This
this
integral
integral will
become
become of the
gives log terms.
x.
So we are going to integrate separately. So minus 4
So
plus 2t upon 4 minus 4t plus t square dt. If we take this term 4 minus 4t, 4 minus 4t plus t square as u, we will get minus 4t plus 2t minus 4 sorry plus 2t dt is equal to du. So this integral becomes du upon u,
u,
which
which
is
is
nothing but log of mod u, which is nothing
nothing
but
but
log of
log of
4 minus 4t plus t square. Again,
again
when we
when we
integrate this
integrate
in
this in
1 upon 4 minus 4t plus
plus
t
t
square
square.
dt. Hello,
Hello.
hello.
हेलो.
तो जब
तो जब
इसे
इसे
इंटीग्रेट
इंटीग्रेट
करेंगे
करेंगे
तो
तो
ये
ये
इस फॉर्म
इस
में
फॉर्म
दिख
में
रहा है.
दिख
एज
रहा
यू
है
कैन सी
एज
दिस इज स्क्वायर
इसका
फॉर्म. You can write
यू
in
कैन
the
राइट
perfect
द
square
परफेक्ट
form
स्क्वायर
as
फॉर्म एज
dt upon t minus 2 whole
minus 2
square.
whole
Can we
square.
write it
Can
like
we
this?
write it like this?
Okay. So this
So this
integration become t
integration
minus
becomes t
2
minus
integration of
integration of
dt upon t
dt
minus 2.
upon
If we
t minus
take here t minus 2
t
as
minus
another
square
variable v,
v.
we will get dt
We
is
get
equal to dv. This integration
this
become
integration
dv upon v square.
v square.
So what is the integration of this?
The
It
integration
will
of this
give
it will
minus
be
1 upon
minus
v
1 upon v
minus 1 upon v
minus 1 upon
because
v
1 upon v
because
square
1
gives
upon v
v raised
square
to
gives
power
v
minus
raised
2.
to power minus
It
2.
gives v
It
raised to power
gives v
minus
raised to power
v1
minus v1
minus 2 plus 1 upon
minus 2
minus 2
plus 1
plus 1
upon
v
minus 2 plus 1
minus
gives
1 upon v.
minus 1 upon v.
So the
So
given integral
the
become
given integral
this
become
integral.
so this integral. So
This whole
this
integral
whole integral
become
become
it become
become
log of
of
sorry 3 by 2
3 by 2
log of
log
4 minus
4
4t plus
minus
t square
t square
minus
minus
here we replace 1 minus 1 value minus 1 upon t minus 2.
t.
So it become minus
It become minus
1 upon t minus 2
1
plus c.
plus
Now
c.
we replace t. Here we
We
have
replace
taken
t.
t as
Here we t as
okay. So this integral
so this
become
integral become
3 by 2
3 by 2
3 by 2 log
3 by 2 log
4 minus
4
4 sine theta
4 theta
plus sine square theta
plus sin square theta
minus 1 upon
minus 1
sine theta minus 2
minus 2
plus c
plus c.
as this form. We have
As
written this
form. We have
integral
written
changing
this
t in terms of
integral
sine. We
changing
get this
t in
integral.
terms of sine. We get this integral.
I hope it is clear.
I
This
hope
type of
it's
question
clear.
clear to
This
you.
type of question is clear to you.
Is it clear?
Is it clear? Okay.
Hello.
Hello.
Am I audible?
Am I audible?
Am I audible to all? Hello.
Am I audible to all? Hello. Okay. So here we have another integral which is the form of x square plus 1, x square plus 4 and x square plus 225. So how we are going to integrate this? How we are going to integrate this? As we can see, are we going to use partial fraction directly? As we know, if we have a this proper upon x square plus uh,
X square plus px plus q. Here it
here
is not
is not
factorizable.
factorizable.
If we have any integral, or there is another factor which is linear factor x plus a.
Plus,
So we
so
write
we write
this integral in the
integral
form
in the
of
form of
a upon x plus a
plus
plus this, what this,
what
it is not
this which is
factorizable, it is not
factorizable.
factorizable. So what we are going to
What
do, we are going to
we
write
are going to
b
write
upon x
b
square
on
plus px plus q, bx plus
bx
c. But here, as you can see, both the
see
factors are in the
are in the
quadratic,
quadratic.
like in the previous one.
This
So
one
first we are going to write,
to
we are
write.
going to take. We are going to take this x square plus
X
1 as y.
plus 1 is
When we take x square plus 1y, this integral,
this
this integral x square plus 1, x
x
square plus 4,
x
x square plus 25, it can be written as y upon
this
x
square
square plus 1 is y. So x
x
square plus
plus 1
so it means x
x
square plus
plus 4
4 will
will
become
become
y
y
plus
plus
3, and x
x
square plus
plus
25
25
will
will
become
become
y
y
plus 24.
24.
Can we
Can you
write it
think
like
like
this?
this?
हम
हम
ऐसा
ऐसा
लिख
लिख
सकते
सकते
हैं?
हैं? Yes, हम ऐसा लिख सकते हैं.
Now,
Now it is in linear factor form.
as you
As
can see,
you can
this
see,
is
this
in
is in
linear
linear
factor.
factor.
Y
Y
plus
plus
3,
3,
y
y
plus
plus
24.
24.
Now
Now
we
we
can
can
use
use
partial
partial
fraction
fraction
form.
form.
Y
Y
plus
plus
3,
3
y plus 24. Hello,
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 hello.
hello.
Am I audible?
Am I audible?
Hello,
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 hello.
hello. Hello. Hello. Hello. Am I audible? Am I audible? Hello. Hello. Am I audible now? Am I audible now? Okay. Okay. Hello. Hello. Okay. So we can write y upon y plus 3 is equal to y upon y plus 24 as a upon y plus b upon y 24. Okay. So this implies y to a times y plus 24 plus b times y plus 3. Um, when we compare the coefficient, this becomes b, y, and here 24a plus 3b. There is the coefficient, what we will get? Here we will get and 24a plus 3b equal to 0. Hello. 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 So what we will get? We can write as minus b upon 8. Can we write it like this? A is equal to minus b upon 8. Now what we get here? When we replace here as a plus b is equal to 1, when we write minus b upon 8 plus b minus b upon 8 plus b is equal to 1, this implies 7b upon 8 equal to 1. This implies b is equal to 8 by 7 and a will be minus 1 by 7. Am I correct? So what? So this become a is b 8 by 7, a is minus 1 by 7. So this integral become means this part we have taken x square plus 1 y upon y plus y plus 24. We are not going to directly substitute it. We are going to write x plus 1 upon x square plus 4 plus 25 dx. Here this we are talking about this is written in this form. This a and y plus 3 is nothing but x square plus 4. So this a is minus and b is 8 by 7 plus 25. Okay. Writing the dx.
Hello, am I audible? My voice is coming. Hello, hello. So this integral become hello. So this integral wait. So this integral become means minus 1 upon 7 dx upon x square plus 4 plus 8 by 7 integration 1 upon x square plus 25 dx. Hello, hello. I think my voice is not good. Hello, 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 hello. My voice is coming. Hello, 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 hello. So, okay. So this integral minus 1 upon 7 dx upon x square plus 2 square plus 8 by 7 integration of 1 upon x square plus 5 square dx. We know there is a formula that which is dx upon x square plus a square gives 1 upon a tan inverse x by a. This is a standard formula. So as you can see, so this integration become 1 minus 1 by 7 and inverse x by 2 into, here we can write 1 upon 2 into minus 1 upon 2 plus 8 by 7 into 1 upon 5 tan inverse x by 5 plus c. It become minus 1 upon 14 tan inverse x by 2 plus 8 upon 35 tan inverse x by 5 plus c. Is this type of question clear? This is important. So whoever is watching in live, please react. Please react. Your reaction may be in the form of like, in the form of comment or anything. You can also press emoji button. So whoever is watching, please react. Okay. So the another question, which is integration e raised to power tan inverse x upon 1 plus x square dx. Okay, think about it. We will discuss this question in 1 minute. Okay. Discuss this question in 1 minute. Okay. Okay. So this is simple. This is the simplest question. Very simple question. Like the previous one, I've given the formula for this. Integration of dx upon x square plus a square gives 1 upon 8 tan inverse x by a. So, so how we are going to integrate this? Just take, as you can see, this is the form of, if we take here, take tan inverse x as t. Take tan inverse x as t. So when we differentiate this tan inverse x, differentiation of tan inverse x, we know differentiation of tan inverse x is nothing but 1 upon 1 plus x square. What is the differentiation of sine inverse x? which is nothing but 1 upon under root 1 minus x square. What is the differentiation of cos inverse x? It is nothing but minus 1 upon under root 1 minus x square. So when we differentiate with respect to t, we will get 1 upon 1 plus x square dx. On differentiating, we get dx equal to dt. So the integral become this integral e raised to power tan inverse x upon 1 plus x square dx become this integral become e raised to power t upon this 1 plus x square and this dx. When we write it as dx equal to 1 plus x square dt means this. So it will be cancelled out. What we will left? We will left with e raised to power t dt. It becomes e raised to power t plus c. Here we have taken t as tan inverse x. So it becomes e raised to power tan inverse x plus c. So integration of e raised to power tan inverse x upon 1 plus x square dx become e raised to power tan inverse x plus c. I hope it is clear. This question is clear. So in inverse trigonometric function, this type of question where we need to take a substitute, we need to substitute this inverse trigonometric function as taking as a variable t, then we differentiate, we will get the standard integral form. Okay. Now we have another type, means seventh type. This integral. I'm giving you 1 minute. Think about it. How we are going to solve it? Are we going to use substitution method or any other method? Think about it. Look, there's a logic here. Or we can say I am giving you a trick, very general trick how we are going to which trigonometric ratio, either cos x or sin x, is going to be a substitution. What we are going to substitute in terms of another variable. Just take integration of sine mx cos nx. Look, this trick only work for mn less than equal to 3, less than or equal to 3. So if you have integration, if m is even, means sine का power, अगर sine का power even है, if m is even, then we are going to take sin s xt. Now else if n is even, अगर cos का power अगर even power है, means it can be 2. Okay. Okay, so we are going to take cos x as t. Okay, so here as you can see, this here sine ka power is 2, which is even. So we are going to take sine x as t. So differentiating with respect to t, what we will get? We will get cos x dx equal to dt. Okay, so this integral sine square x cos x dx, it will become t square. Now this cos x dx become dt. Simple. So now the integration of this is, we know integration of x is upon n dx is x is upon n plus 1 upon n plus 1 plus c. We all know about this. So the integration become t raised to power n plus 1, which is 3 upon 3 plus c. Now here t is sin x, so we replace this is sine cube x upon 3 plus c. This implies this integral sine square x cos x dx becomes sine cube x upon 3 plus c. Okay, remember this. Remember this. This is only valid for m1 and less than equal to c. Now I'm going to tell you what happen if m and both are even. Means if we take m and n both are equal to 2. How are you going to solve this? Sine square x cos square x dx. We know this form sine 2x equal to 2 sine x cos x. So we can write this as when we multiply and divide by 2 square, we get sine square x cos square x dx. It will become 1 upon 2 square. The inner integral, when we place this inside the integral 2 square, it becomes sine 2x whole square dx. We all know this, and we also know this that 2 sine square x is nothing but 1 minus cos 2x by 1 minus cos 2x. So we replace 1 upon 2 square and integrate. We replace sine 2x square, means this it will become 1 minus cos 4x by 2. 1 minus cos 4x by 2 dx. Now this is the known integral. When we take out this 2, it become 1 by 8. It become dx minus 1 by 8 integration of cos 4x dx. And we know the integration of this become 1 upon 8 x minus 1 by 8. This integration of this cos 4x is sine 4x by 4 plus c. So this is important whenever you encounter this type of integration where it has sin x term, cos x term, and it has a power form m into sin x to power m and cos x to 1. If m is even, we are going to take sin x xt. If n is even, cos x is going to. If m and n both are even, we are going to form in this form. We are going to make this form sin 2x equal to 2 sin x cos x. In your exam, only power 3 will appear, not more than 3. Okay, so this is important. Now next question is of the form sin x sin 2x sin 3x dx. Dx dx. Try to solve this. You have 1 minute. We will discuss this. How are you going to integrate this? Okay, done. In the previous question, if we have a term which is in the power, if we have a trigonometric ratio sin x cos x, in the power we have found sin square x cos x. Now here in this term, in this trigonometric ratio, we have multiples of angles, arguments, sin x, sin 2x, sin 3x. We know we are going to use a property. We know what we know, that cos of a minus b, cos of a minus b plus cos of a plus b, what it gives? Cos of a plus, it gives 2 times cos of a cos of b. We all know this property. The same way, cos of a minus b minus cos of a plus b, what it gives? It gives 2 sin a sin b. Am I clear? And what about this? Sine of a minus b plus sine of a plus b. What it gives? It gives 2 times sin a cos b. The same way, if we place a minus sign, means if we have a sine of a plus b minus sine of a minus b, what we will get? We get 2 cos a sin b. 2 cos a sin b. So we are going to use this property to evaluate this type of integral. When the integral, if the term sin x times sin 2x times sin 3x. So this integral, this this integral can be written as integration, or we can this integral sin x sin 2x can be written as 1 upon 2 2 times sin x sin 2x sin 3x dx. Now when we take out 1 by 2, this 2 sin x sin 2x, we are going to use this. So it will become in this 2 sin a, means we are going to write cos of x minus 2 minus cos of x plus 2x sin 3x dx. Now this integral becomes 1 upon 2. Again, we are not going to integrate directly. We are just first we write in this form cos x. In the whenever you encounter the integral, जब भी integral ट्रिग्नोमेट्रिक रेशियो के प्रोडक्ट फॉर्म मिल गए, उसे हमेशा दो ट्रिग्नोमेट्रिक रेशियो, दो या दो से ज़्यादा ट्रिग्नोमेट्रिक रेशियो को प्लस और डिफरेंस फॉर्म में लिखना पड़ेगा हमें. हाँ, और हम इसे करने के लिए हम ये वाली प्रॉपर्टी यूज करेंगे. We will get cos x minus cos 3x sin 3x dx. Again, 1 upon 2 integration cos x. Am I audible? Am I audible? Okay. So cos x sin 3x minus cos 3x sin 3x dx. We will left with 1 upon 2 integration of. Now we can write cos x 3x. It is in the form of fourth form, as you can see. So it will become 1 upon 2 2 cos x sin 3x minus 1 upon 2 times 2
cos 3x sin 3x into dx. We know there's another form. Sin 2x is nothing but 2 sin x cos x. Okay, so it means when we replace x by 3x, what we will get? It will sin cx will be 2 sin 3x cos 3x. So what we will get? It will become, wait, it is lagging. Laptop is lagging. Okay, I hope it is working. 1 upon 2 integration of 1 upon 2. Now this 2 cos x sin theta, it is of the form of fourth form. So we can write sin x plus 3x minus sin x minus 3x. Okay, can we write it like this? Okay, minus 1 upon 2. This becomes sin 6x. I think it is lagging. So this integral become integration of 1 upon 4 sine 4x minus, or we can say it is sine 2x, because sine x minus 3x gives sine minus sine 2x, it becomes sine 2x. The whole become integral dx minus 1 upon 4 integration of sine 6x dx. Okay, so this integral become 1 upon 4 integration of sine 4x dx plus 1 upon 4 integration of sine 2x dx minus 1 upon 4 integration of sine 6x dx. This become 1 upon 4 minus cos 4x 4 plus 1 upon 4 minus cos 2x by 2. This become minus 1 by 4 times minus sine 6x minus cos. Wait, there is a difference. As we can see, this term, this integral, here this integral 2 cos x sine 3x, this integral. Am I audible? There's a minus sign. There's a difference of minus sign. Wait, this integral. Sine of a minus b. This become 2 cos a. Sine of a plus b gives sine a cos b plus cos a sine b. So this become 2 cos a sine b. Okay. There's a difference of minus sign. So when we take this integral, we will get plus c. Wait, wait, there is a problem. Hello, am I audible? Am I audible? Hello. Hello. Huh. So here as you can see, there's a mistake. Here we can write this sine of x plus 3x as minus of sine x plus 3x sine of x minus 3x. Because when we expand this, we write as sine of a minus b gives sine a cos b minus cos a sine b. So whenever we write this form, so we left with wait wait, there is the issue. Wait, wait. I'm audible. I'm audible. Hello. I'm audible. Hello. Is this line correct? If this line is correct, as sine of a minus b gives sine a cos b minus cos a sine b. The same way sine a plus b gives sine a cos b plus cos a sine b minus of sine of a minus b gives sine a cos b minus cos a sine b. So this minus become plus, which become 2 cos a sine b. Okay, so we have written the same thing here. This part cos x sin 3x and sin 3 cos 3x minus sin 3x, because when we distributed this we can write 2 sin x sin 2x, means we need sine terms, and we know cos of a plus b gives cos of a cos of b minus sine of a sine of b. Okay, cos of a minus b gives cos of a cos b, plus sine of a sine b. So here we have plus sine of sine b, so here we have got this. So this implies x minus 2x, x plus 2x. Okay, again we left with this, so this part is also correct. So now we have to write 2 cos x sin 3x, 2 cos x sin 3x. So what we are going to write, we need cos term first and sin term second. Or we can also think about this as sin 3x means, wait wait, we can also think as cos x sin 3x, or 2 cos x sin 3x, or we can also think as 2 sin 3x cos x. Can we think about this? So when we think about this, we write 2 sin 3x cos x. When we take 2 sin 3x cos x, means we are talking about this sine of a plus b plus sine of a minus b. When we write it in this form, sine of a plus b means sine of a is 3x, b is, so it will become sine of x plus sine of, this become sine of 3x plus x, okay, plus Sine of 3x minus x. Sine of 3x minus x. Okay, we get the same thing. Okay, so what we will left with, we will left with sine 4x plus sine 2x minus 4 sine. So we can write this 2 cos sine 3x either in this form or either in the second last form. So this integral become sine 6x become minus cos of 6x. So this integral become uh, cos of 6x upon 24 minus 1 upon 16 cos 4x minus 1 upon 8 cos of 2x plus c. This is the required answer. I hope it is clear this type of integral. So whenever you encounter this integral, try to write in the sum or difference of trigonometric ratio, either cos term or sine term. Now this integral. So I am giving you 1 minute. Try to think about it. How we are going to solve it. This integral. Okay. So we have a we have an integral of the type this. Here integration is, I think it is lagging. It is not working. That is why p of x plus q px plus q upon under root ax square plus bx plus c. So whenever you encounter this type of integral, try to write in the partial fraction form, where the terms of the partial fraction will be written in the form of, we are going to split this integral in this form: a times differentiation of the under root term ax square plus bx plus c plus b upon under root ax square plus bx plus c. So when we find out a and b, we will split this type of integral, this integrand, into sum of two different terms. So what we are going to do here, it is given 3x plus 5. So we are going to write 3x plus 5 under root x square minus 8x plus 7 in the form of a times differentiation of x square minus 8x plus 7 plus b upon under root x square minus 8x plus 7. So this implies we compare the numerator 3x plus 5 times a times 2x minus 4 plus p. I think it is lagging. So we write it as 3x plus 5 is equal to minus 4a. I think it is lagging. plus b plus 2ax. So when we compare the coefficient, it is lagging too much. Tablet is lagging. We compare it. Wait, why it is lagging too much? You're not right. Close. Is it okay now? Let me check. Let me check it first. Is it working? Is it working? Still lagging. Okay, we will try to finish it. Here, when we compare the coefficient, what we will get? A is equal to, this implies A is equal to 3 by 2 and minus 4a plus b will be, minus 4a plus b will be 5. When we substitute these values, a in place of this, we will get minus 6 plus b is equal to 5. We'll get b is equal to 11. A is equal to 3 by 2 and b is 11. Is it correct? So when we differentiated it, we will get my 2ax minus 4a plus b. Okay. So the integral becomes, this integral 3x plus 5 upon under root x square minus 8x plus 7. Is it 7? Yes, it is 7 dx. It become integrand of a. A is हमारे पास a है 3 by 2. Now differentiation of this means differentiation of the denominator part, which is 2x minus 4 whole upon under root x square minus 8x plus 7 dx. We don't write, just first we split it, then we write. Here b is, when we substitute b means 11 upon under root x square minus 8x plus 7. Okay. Okay. So we can write it as this form. Hello. Am I audible? Am I audible? Am I audible? Okay. So this integral become 3 by 2 under root 2x minus 4 upon under root x square minus 8x plus 7 dx plus 11 under root dx upon
under root x square minus 8x plus 7. Now this integral 2x minus 4 upon x square minus 8x plus 7 dx. It is of the form of, this integral it is in the form of f dash x upon f of x dx. So we take f of x as t. So in the same way, if we take x square minus 8x plus 7 as u, let me 7 is equal to u, what we will get? 2x minus 4 dx is equal to du. We will get this. In the same way, what we will left with du upon under root u. I think my tablet is lagging. It will become, when we integrate it, what we will left with? It was minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. It is too much lagging. Under root u upon 1 by 2 plus c. So 2 under root u plus c. So we will left with 2 times x square minus 8x plus 7 plus c. Now this integral dx upon under root x square minus 8x plus 7. Now how we are going to solve this integral? X square minus 8x plus 7. What we are going to do? We will try to write x square minus 8x in the sum of difference of two squares. So we are going to use the method of completing the square. So we write x square minus 8x plus 7 as x square minus times minus 2 times 4x plus 4 square minus 4 square plus minus 4s plus 7. It will become, this will become x minus 4, this will become x minus 4 whole square, minus 4 square gives 16, minus 16 plus 7, minus 16 plus 7 gives minus 9, which is nothing but x minus 4 whole square minus 3 square. Is it clear? So we can write it as dx upon integration of x minus 4 whole square minus 3 square. Okay? So as you can see, this integral is of the type, okay, dx upon under root x square minus a square. Wait, wait. Okay, now audible now? Okay. The integration of this is nothing but log of mod of x plus under root x square minus a square plus c. We all know this integral. Okay. So what will be the integral of this? It will be nothing but log of mod of x minus 4 plus under root. The under root term is this x square minus a square, which is nothing but x square minus 8x plus 7. So our integral means this integral. We are finding this integral. So this integral become means integration of 3x plus 5 under root x square minus 8x plus 7 dx. This integral becomes 3 by 2 times 2 under root x square minus 8x plus 7 plus 11 times log of x minus 4 plus x square minus 8x plus 7 plus 3. So we cancel out, we will left with 3 times x square minus 8x plus 7 plus log of mod x minus 4 plus under root x square minus 8x plus 7 plus 3. So required integral. Is it clear to everyone? Is it clear? Then our last question of this slide of today's slide is this x integration of x minus 3 under root 3 minus 2x minus x square. So you have 3 minutes for this question. Think and try to solve it by yourself. Okay. So how we are going to proceed in this question? Wait. There is audio issue.